Welcome. Welcome to this quiet corner of the universe, a place where perhaps we can ponder some of its most curious workings and time. You see, for a long time, we thought of space as a kind of empty stage, a fixed backdrop upon which the drama of existence unfolded. Well, time was a steady, unwavering river flowing at the same rate for everyone and everything. Simple, wasn't it? Elegant even. But nature, it seems, often has a deeper, more intricate story to tell. And it began with a puzzle, a rather perplexing observation about light, the mystery of light. Imagine you are on a train hurtling through the countryside. If you throw a ball forward, its speed adds to the speed of the train, doesn't it? And if you throw it backward, its speed subtracts. It seems perfectly logical, this addition and subtraction of velocities. But what happens with light, that ethereal messenger that carries the very images to our eye? Experiments showed again and again that the speed of light in vacuum, a staggering 300,000 kilometers per second, remains constant, regardless of the motion of the source emitting it or the observer receiving it. Think about that for a moment. Imagine our speeding train. If we shine a flashlight forward, wouldn't you expect the light to travel even faster? But no, it stubbornly insists on its own unwavering speed. It was as if light had its own set of rules, a cosmic speed limit that nothing could surpass, and that everyone, no matter how fast they moved, would always measure the same. This realization, it was like a crack in the foundation of our understanding. If the speed of light is constant for all observers, then something else must be at play. This idea opened up a realm of questions that would unravel the fabric of physics. What if time itself was not as fixed as we believed? The train, the light, and the observer all existed within a dance that challenged every notion we held dear. This was the dawn of a new understanding where relativistic principles began to reshape our reality. This fascinating concept reveals the intricate relationship between speed and time. As the moving observer continues on his journey, he experiences moments stretching before him while the world around the stationary observer ticks away at its usual pace. The reality they share is now a complex dance of perception, where their experiences of time are not in sync, leading to profound implications for our understanding of the universe. Relative, and what is this? Something else. It is the very fabric of space and time itself. You see, to keep the speed of light constant for everyone, space and time must be intertwined, they must be flexible. They are not the rigid, independent entities we once believed them to be. Instead, they are two aspects of a single, unified entity, space-time. Imagine two observers, one standing still and another moving at a very high speed. If the moving observer shines a light beam, both observers must measure its speed to be the same. But for this to be true, something has to give. For the moving observer, time will actually pass slightly slower than for the stationary observer, and distances in the direction of motion will appear slightly shorter. It sounds like science fiction, doesn't it? But it is a fundamental truth of our universe confirmed by countless experiments. Time is not absolute. It is relative to the observer's motion. And space too is not immutable. It can contract or expand depending on your speed. Think of space-time not as a stage, but as a kind of cosmic tapestry. When something moves through this tapestry, it stretches and warps it ever so slightly. And the faster it moves, the more significant these distortions become. Now, what about gravity? For centuries, we understood gravity as a force, an invisible pull between objects with mass. Newton gave us a magnificent framework to describe its effects. But there was always a lingering question. How does this force act instantaneously across vast distances? My theory of general relativity, which built upon the special theory we've been discussing, offers a different perspective. It says that gravity is not a force at all, but rather a consequence of the curvature of space-time caused by the presence of mass and energy. Imagine placing a heavy ball on a stretched rubber sheet. The ball creates a dip, doesn't it? Now, if you roll a smaller ball nearby, it will curve towards the heavier ball. Not because of some direct pull, but because it is following the contours of the warped surface. Similarly, massive objects like the Earth and the Sun warp the space-time around them. And when other objects like you or I move through this warped space-time, we follow the curves created by these massive bodies. This is what we perceive as gravity. The Earth doesn't pull us down. We are simply following the path of least resistance in the curved space-time around it. So what does all of this mean? It means that our universe is far more dynamic and interconnected than we ever imagined. Space and time are not separate and rigid, but a flexible, interwoven fabric that is shaped by the matter and energy within it. The speed of light is not just a speed limit, it is a fundamental constant that dictates the very nature of space-time. And gravity is not a mysterious force, but a beautiful consequence of the geometry of this cosmic tapestry. The harmony of the universe reveals itself in the interactions between matter-energy and the invisible forces that govern them. Each planet, star, and galaxy plays a role in this grand design, influencing one another across vast distances. Understanding these connections unlocks new perspectives on our existence, showing that we are part of a much larger story, where even the smallest actions resonate through time and space.